This is a quick introduction to Slifer. I go to the MATLAB command line, type in Slifer. Up comes a default 21 coefficient FIR filter you see up in the upper right hand corner here that I can set that value to other numbers if I wanted to, but that establishes the number of coefficients which are shown in this window here, which I could modify directly if I wanted to. I could do that either by moving with the mouse, or I could even come over and change, and again in the upper right hand corner, the coefficient by some amount and type that quite precisely rather than just sort of roughly with the mouse. I could also come down to the lower right corner and grab the pole 0 pattern. In this case it's only zeros because it's FIR, and I can move those, manipulate those, but as I do, I find that that's a pretty crude tool to try to get a good match between my target profile, which is this red thing, which is trying to guide my design, and this yellow curve, which is my frequency response of those coefficients that I'm looking at this particular snapshot. So it's a pretty rotten job right now. I can click back on here to set it again, and you notice that I've got these little circles. Now these represent the frequency samples, which are located at certain frequencies down here, which are spaced by multiples of 1 over 21 in normalized frequency terms. I can actually click on a grid to make that a little bit more visible. Now I can change those using the venerable design technique called frequency sampling, and move the altitude of those points along that grid line, and I can perhaps cause this to increase or decrease my ripples and create a better filter. But more potent than that is to extend from basic frequency sampling, going up to the upper left hand corner using setup to follow target mode, and click again to reset. And now these little pearls, as we call them, or interpolation knots, are able to be moved sideways as well, and they're riding exactly on the red target line. And bearing in mind that equi-ripple filters have non-uniformly spaced extremal frequencies, well, they also have non-uniformly spaced points on the target profile. I could probably, with enough time, get myself by manipulating these things an equi-ripple pass band, maybe also stop band. But I have even another card to play by going back up to setup and going to full freedom mode. This allows me to combine these two possibilities, that is, going vertically and also left and right, and moving the samples wherever I want them, including the possibility to cluster them up to cause good behavior in a very limited band if that should suit my design requirements. Of course, I have to be careful because the design escapes elsewhere and may be quite bad if I get very ill-conditioned Vandermonde matrix, which is guiding the inverse transformation of these samples and taking me back through inverse DFT to get through an inverse Vandermonde matrix to get my coefficients. I have, through the combination of these operations, the ability to handcraft with great flexibility and meet very difficult design requirements.